Welcome to the video on readers and writers problem. Classical problems of synchronization. These are the three examples discussed in the textbook. One is a bounded buffer problem, readers and writers problem, dining philosopher problem. In this video, we are going to discuss a readers writers problem. And the prerequisite, you should know a semaphore. Let us consider a file is shared among the several concurrent processes. Few processes may want only to read the file and other few processes may want to update or they want to write into the file. Now there are many processes. The processes we are going to classify as a readers and a writers. Readers only read the dataset or you can say the file. They do not perform any updates. And the processes we are going to classify as the writers if they can do both reading and writing. Let us take an example. We have a P1, P2, P3, P4 and one more P5 process. And P1 and P4 are readers, means they will not write anything into the files. Whereas P2, P3, P5 are writers, means they update the file, they write into the file. Like that, in general, we are going to have a two classification, one as a readers, another as a writers. Now in this, we are going to talk about how the synchronization can be achieved between the readers and writers using a semaphore. Try to understand. Only one writer is allowed, means only one writer is allowed to enter into the critical section. Even in general also you think two persons cannot write in the notebook, but more than two persons can read from the notebook. Like that, use your common sense and try to understand. If a writer is writing, no reader or writer is allowed. Multiple readers may be allowed. There is no critical section for them because two persons can read without affecting each other. If a reader is reading, writer is not allowed. So this is what we expect from our program. We should fulfill this. So read it once again, try to understand. We have some semaphores and variable we are using. WRT is a binary semaphore we are using between the writers and readers and writers. It is initialized as a 1 and this WRT is accessed or used by the first and last reader. I have many processes as a readers. This WRT is accessed by the first and last reader. Now the read count is a variable, integer variable, initialized to 0. This gives the information how many processes are currently reading the file. If no process is reading the file, then it is 0. Another mutex we are using a semaphore. It is a binary semaphore between the readers for updating the read count, because read count is a shared variable among the readers. Only one reader should access this read count at a time. For that we are using a mutex. Read this again, try to remember, then we'll go to the next slide. Writer logic is very simple to understand, to write. What we do, being a writer, wait for the WRT semaphore, ensure that no other writer is writing. Once we come to know nobody is writing, perform the writing operation, then give the signal WRT so that another process can start writing. The concept is very simple. This is from the previous slide. What you have done, the same thing we are writing a program. While to, always it will execute. Wait for the WRT. Ensure that nobody is writing. Then you start writing. Once if you finish writing, give the signal WRT so that another process can start writing or maybe reading. Try to answer the following. If the reader is reading, whether the another process, a writer is allowed or not? No. Next, if the writer is writing, the reader is allowed? No. If the writer is writing, another writer is allowed? Try to answer. No. If the reader is reading, the reader is allowed? No. Yes. Why? More than two readers can read at a time. So you can pause, you can go back to the previous slide, try to understand. The structure of the reader process, in that we use a WRT semaphore, we use a read count integer variable, mutex semaphore for updating a read count. Try to understand these two lines. If some reader is reading, wait for the mutex, then increment the read count, then signal the mutex, because read count is shared among the many readers. If it is a first reader, then wait for the write WRT semaphore. Why? If you are the first reader, ensure that nobody is writing. Then wait for the mutex to update the read count. Then give the signal to the mutex so that other readers can enter into the reading operation as well as they can update a read count. If it is a last reader, then I have to signal the WRT, because some process may be interested to do the write operation. Being a last reader, it's my duty. I had to signal the WRT so that another process writer can enter the writing operation. The structure of the reader process: while true, check for the mutex, or you can say wait for the mutex, increment the read count. I am waiting for the mutex so that I can increase the read count. Then I'll check after reading the incrementing the read count. If I'm the first reader, then what I have to do? Then check that nobody is writing. That's why wait WRT. Then I have done the read count already plus plus. Then signal the mutex so that others reader can read and they can increment the read count and signal the mutex. Next, reading is performed. Once reading is over, then we have to decrement the read count. Can I write read count minus minus? No. Why? Read count is a shared variable. Therefore, wait for mutex, then read count minus minus. Your work is over. Give the signal to the mutex, and if you are a last reader, give a signal to the writer so that they can start writing and signal the mutex. So this is a basic working of a read process. So please read it once again and try to understand the concept. These are the steps. For all these steps, we have made a program or a instructions written. The summary is very simple. First, reader should wait for the WRT. It is given here. And the last reader should signal the WRT. The same color is mentioned. Try to understand this. Each reader waits for the mutex to update the read count. You can see here. And then signal the mutex so that others can update the read count. So pause here, try to understand, revise. These are the books which are referred. Thanks for watching this video. Share this video if you like and subscribe this YouTube channel. Thank you.